Hey guys, welcome back. In our Understanding Big Data Problem lesson, we saw that HDFS or Hadoop Distributed File System takes care of all the storage related complexities in Hadoop. In this lesson, let's understand more about HDFS. More importantly, why there is a need for another file system like HDFS. Let me start this lesson by asking a question. Have you used any file system before? The answer has to be yes. Just the fact that you're using a laptop or your portable device to watch this lesson, you're using a file system indirectly behind the scenes. File system is an integral part of every operating system. It basically governs the storage in your hard disk. Take a look at this slide. Let's say I give a person a book and I give another person a pile of unordered papers from the same book. And I ask each of them to go to chapter 34. Who do you think will get to chapter 34 faster? The one with the book, right? Because he can simply go to the index, look for chapter 34, look up the page number, and go to the page. Whereas the one with the pile of papers has to go through the pile of papers, and if he is lucky, he might find chapter 34. Just like a well-organized book, a file system helps to navigate the data that is stored in your storage. Without the file system, the information stored in your hard disk will be one large body of data where no way to tell where one piece of information stops and the next begins. Here are some of the major functions of a file system. File system controls how the data is stored and retrieved. Basically, when you read and write files to your hard disk, your request goes through a file system. Next, file system has the metadata about your files and folders. Metadata information like file name, size, owner, created, modified time, etc. File system also takes care of permissions and security. File system manages your storage space. So when you ask to write a file to hard disk, file system helps figure out where in the hard disk it should write the file. And it should write the file as efficient as possible. In the beginning of the lesson, we mentioned that the file system is an integral part of your operating system. So let's look at some of the popular file systems that are already out there. Okay. Although very old, the most legendary file system from Microsoft is FAT32. Maximum file size a FAT32 file system can support is 4 GB. So if you have a file which is 5 GB in size, you're out of luck with FAT32. And it has a 32 GB volume limit or a logical drive limit. So your drive can be of size 32 GB and not more with FAT32. The numbers listed in this slide are baseline numbers, okay? The size limits can be more or less based on the file system configuration. So, if you use Windows 95, 98 or Millennium version, you probably use FAT32. Next generation file system from Windows after FAT32 is NTFS, New Technology File System. And it supports 16 exabyte file and volume limit. 16 exabyte, that is a very huge number, right? Which is 1024 petabyte. So NTFS can clearly support huge volume of data. Starting Windows Server 2012, Windows introduced REFS, Resilient File System. I'm using Windows right now, so how do I know what is my file system? It's very simple to find out actually. Just go to My Computer and select a hard drive. There you go. The file system of my operating system is NTFS, which is shown at the very bottom. So that's how you find a file system in Windows. So going back to the slide, let's look at file systems from Mac. HFS, or Hierarchical File System, is a legacy file system from Mac. Apple started using HFS Plus from Mac OS 8.1 and above. For example, if you used iPod, you would have used HFS Plus. HFS Plus can also handle huge volume of data up to 8 exabyte in size. Next, let's go to Linux. ext is the most popular file system in Linux. ext3 is the third generation file system in use since 2001. Then came ext4. ext4 can support individual file sizes up to 16 terabyte and volumes up to 1 exabyte. Next comes XFS. XFS is created by Silicon Graphics and it can support up to 8 exabyte in file and volume limit. How can you look up your file system in Linux? Let's check it out. Simply log into a Linux terminal and type in df-t. There you go. Here you can see the file system. So ext4 is the file system of this Linux installation. Also, the operating system of this Linux is Ubuntu 14.04 and the file system being used is ext4. So clearly recent file systems can handle individual file sizes up to 8 exabyte or even up to 16 exabyte, right? So clearly we have file systems where we can store big data sets. Then, what is the need for HDFS? Any guesses? No, seriously, take a guess. Let's recap what we learned from the understanding big data problem lesson. We saw that to support truly parallel computation, we had to divide the dataset into blocks and store them in different nodes. And to recover from data loss, we also replicated each block in more than one node, right? Take a look at this slide. Assume you have a 10-node cluster and you have ext4 as the file system on each node, like this right here. We will refer ext4 on each node as the local file system and we will see why. So the first task of your proposed file system is, when you upload a file to this proposed file system, you need the file system to divide the dataset into fixed size blocks. Although every file system has a concept of blocks, the concept of blocks in HDFS is very different when compared to the blocks in traditional file systems. We'll see the differences in another lesson. Next, your file system should have a distributed view of the files or blocks in your cluster, which is not possible with your local file system, which is ext4 in this slide. What I mean is, your local ext4 file system on node 1 has no idea what is on node 2. Similarly, node 2 has no idea of what is in node 1. Because since the ext4 file systems in both node 1 and node 2 are local to each node, there is no way they can have a global or distributed view of the entire 10-node cluster. That is why we say the ext4 on individual nodes as local file system. Make sense? Next important thing is replication. This adds a lot of complexity, right? Since ext4 in node 1 has no idea about storage in any other node, it does not have the ability to replicate blocks in node 1 to the other nodes. So which means we are exposed to data loss, and that is very bad. So now assume we have a file system on top of ext4, but only this time it spreads across all the nodes. And there you go. We call that file system Hadoop Distributed File System. So now when you upload a file to HDFS, it will automatically be split into 128 MB fixed size blocks. In the older versions of Hadoop, the file was divided into 64 MB fixed size blocks. Okay. So HDFS takes care of placing the blocks in different nodes and also take care of replicating each block into more than one node. By default, HDFS replicates a block to 3 nodes. So let's say you copy a 700 MB dataset into HDFS. HDFS will divide the dataset into 128 MB blocks. That is the first step. So you will have 5 equal sized 128 MB block and one 60 MB block. Make sense? So that is a total of 700 MB. Since HDFS has a distributed view of the cluster, it can easily decide which nodes should hold these 6 blocks. and also pick the nodes to hold the replicated blocks. HDFS will continue to keep track of all the blocks and their node assignments all the time. So when a user asks about the 700 MB dataset, it knows how to construct the file from the blocks. So let me ask you a question. This is an excellent interview question. Ready? When you have HDFS, what happens to the local file system which is on each node? Take a guess. Here's the answer. HDFS by no means is a replacement for your local file system. Your operating system still rely on the local file system. In fact, your operating system does not care about the presence of HDFS. One more interesting thing. HDFS should still go through ext4 to save the blocks in the storage. As you can see, HDFS is placed on top of the local file system. The true power of HDFS is that it is spread across all the nodes in your cluster. And it has a distributed view of the cluster, and hence it knows how to construct the 700 MB dataset in our example from the underlying blocks. Whereas the ext4 does not have a distributed view and only knows about the blocks in its storage that it is managing. Okay, that explains the need for the new file system like HDFS in a distributed environment like Hadoop. Let's summarize the benefits and functionalities of HDFS. First of all, HDFS supports the concept of blocks. When you upload a file into HDFS, the file is divided into fixed size blocks to support distributed computation. And that is key for Hadoop. Also, HDFS keeps track of all the blocks in the cluster. Second, data failures or data corruption are inevitable in any big data environment, even in small environments, right? So HDFS maintains data integrity and help recover from data loss by replicating the blocks in more than one node. Third, HDFS supports scaling. That is, if you like to expand your cluster by adding more nodes, it's very easy to do with HDFS. The last one, you don't need any specialized hardware to run or operate HDFS. And this is very important because we are talking about potentially hundreds of nodes. HDFS was built ground up to work with commodity computers. So let's summarize what we learned in this lesson. First, we looked at what is a file system and its functions. And we also looked at the major file systems that are available right now. Next, we talked about the need for a new distributed file system like HDFS and compared a local file system like ext4 with HDFS. And finally, we saw the benefits of HDFS. Okay, with that, let's wrap this lesson. See you in the next lesson.